Okay, so we're going to look at geometric series, but this time what we're going to do is we're going to have a look at geometric series. Okay, what happens when we keep adding these up? So if you look at this one here, see how this number, remember, between -1 and 1, so r is 2, it's over here, so it's on the outskirts. So if I keep adding this up, the sum to infinity, if I've got an infinite amount of terms, it's going to be infinity. But look at this one, the sum to infinity. If you go and put this into your calculator, which I want you to do, you'll get 3 plus a half plus a quarter. So you're going to be adding little bits and little bits. It won't get anywhere near infinity. So what do we do when that's the case? If I want to find out the sum to infinity, there's the infinity sign. This is the formula. Now, I can only use this when r is between -1 and 1. So r's got to be in between here and here. Okay, and that's when I can use this formula. The proof here is because when r is less than 1, remember the r goes in the second in the bracket. And what happens to this, if I've got a fraction like half to the power of a million, you'll get a number that's so close to 0. So that's what that means. Okay, so as n gets really big, r to the n gets close to 0, so that just becomes 1 on the top. So that's where the formula comes from. So let's see how we work this out. They tell you, find the sum of the infinite series. So that's telling us that we want to find the sum to infinity. There's my formula. So just check to see if it's on your formula sheet. Okay, so we can see here that the r, what am I doing to get to there? I'm dividing by 3, but I need the timesing. So if you're not sure how to find that out, just go T2 divided by T1, 2 over 6, which is 1/3. Okay, so a is 6, so this becomes 6 over 1 minus 1/3, which is 6 over 2/3, which is 6 times 3 over 2, because that's the division, all right, which is 9. Okay, so the sum to infinity, if I kept adding this up, it'd get close to a number, pretty close to 9. Okay, in the last exercise, what we're actually going to do, we're going to learn how to write repeating decimals using geometric series. So let me just open this up. So what have we got here? What I've got here is I've got 0.5 repeater. So that's really the same as 0.5555, etc., etc. If I write these as a fraction, so that's like saying 0.5 plus 0.05 plus 0.005 plus, see the pattern? Which is the same as saying 5 over 10 plus 5 over 100 plus 5 over 1,000. Can you recognise what this is? This is a sum to infinity where a is the first term, 5/10, which actually simplifies down to a half. And the r, what am I doing to get to there? So I'm actually timesing by 1 over 10. Times the top by 1, times the bottom by 10. So my r is 1/10. Hello? Since my absolute value of r, so r falls between -1 or 1 because it's only a tenth, I can use the sum to infinity. So it's a 1 minus r, which is 1/2 over 1 minus a tenth. I'll go over to here, which is a half, divided by 1 minus a tenth is 9/10, which is a half times 10 over 9, which happens to be 2 into that goes 5, so I'm left with 5/9. So that's how you can change a repeating decimal into a fraction. It's pretty good, isn't it?